Okay, we're on. So, no mic, I'm just gonna put my hands in my pockets. Welcome to dorkbotSTL, STL, the premiere. And so today we have Brian, Puzzle Master, and Saria from Syna So Pro is supposed to be here, but we're having technical difficulties with her getting here. So we're just gonna, see what happens today and continue on and do this again, right? And it's a really cool idea. It is, Dorkbot is about doing strange things with electricity. And I would say I don't do a ton of strange things with electricity. I play with, I actually did bring my Raspberry Pi, and I'm making a servo motor camera for my shop. I didn't get to make it in time for this, but probably the next one. And I've messed around with Arduinos, and I'm a programmer, and but I am really interested in, like people just doing these really cool one-off projects and stuff. So Dorkbot is gonna really be a lot of fun to see people's projects, and we want people to know that they can talk about, just the smallest thing that they're making, bring in a project that they finished, or talk about something. Some skill they have, and maybe try to pass along some knowledge on it. So yeah, I would say definitely right if you want to get in touch with us, if you would like to present. So yes, I guess we should just go ahead and get it started, right? And so we have Brian, Brian the Puzzle Master. And you know what, Brian, before I let you go on, I didn't even introduce myself, did I? I'm a really bad MC. I'm Autumn Wiggins. I own the Upcycle Exchange, and I run Strange Folk Festival. And yeah, I'm kind of a dork. I guess that's why they asked me to do this. Yeah, right? Peter knows.
We all did.
He knows what a
Come
dork
to
I
this
am.
and not joking.
She's a dork.
Okay, I'm gonna make a dorky exit and let Brian take over.
All right, it's dork number 2. All right, thanks. Thanks for coming. You can't sit back there though.
Oh, why?
No. Gotta come up. No,
There's room in the front row.
you can sit, as long as you're, say, in front of these 2 pillars. So like that's
Okay,
the furthest you
fair
can
enough.
sit.
Okay.
All right, that's good. Yeah, unless you're holding a baby. Although even if you're holding a baby, you really should come sit up in front, because this is how you train your baby to be a
math
Dorkbot. So, I'm Brian Clare. In my day job, I'm a math professor, computer science professor at SLU. And I'm talking about sensation puzzling. Nope. Come on. I'm gonna just click. Nope, that's not gonna work. Come on. Okay. Ah. Forgot to do that.
Thinking about it?
Not today. How am I going to make this go one slide at a time?
Did her keeper?
Skipping. All right, I'll just take it. I'll take it as it. What?
Gotta talk fast.
This is electricity doing strange things with people.
All right. Well, I'm glad I'm not. All right. Arrow. Okay. Yeah, so I'm a professor in my day job, and last semester, the fall semester, actually at the end of summer, I went to a puzzle room out in University City with some friends, and we didn't get out. We were frustrated, and I was up till like 3 in the morning that night, tossing and turning in bed, thinking of how to make a better puzzle room. And I had what I thought was a pretty good idea, and so I sort of got obsessed, and over the next couple months, I put together all the pieces, and then from October to December of last year, I ran this in the conference room at SLU. That's a picture of the conference room. Turned out to be really popular. I advertised it through the sort of internal SLU thing. So you could do it if you weren't from SLU, but there was no way to find out about it, really. I wasn't charging to do it, and I got 36 groups actually did it. I could have had probably 20 more if I'd wanted, but I started turning people away because I was getting sick of running. So yeah, so some 260 people went through, and about 2/3 of the groups got out, which I was really happy with. I felt like the groups that got out deserved it, and the ones that didn't. If you want to know what a group that doesn't get out of a puzzle room looks like, why they didn't bring enough people, which was irritating because I told them to, or the first thing they would do was sit around the table and have a meeting, right? And that was like some of the staff groups would be like, you know, one of the staff groups would have their manager bring the staff as like a team building activity, and the first thing they'd all do was sit around and see what the manager had to say. It's like, no. They need to spread out and start working on the puzzles. So that's a little background on this room. The theme of this room was the 5 senses, right? That's why it was called Sensation. People didn't know that until they got there. So the general setup, which I did literally come up with that night after doing the City Puzzle Room, was that there were going to be sort of 2 stages. The first stage was you had to find 5 keys hidden around the room, so physical keys. And then you use those keys to open a box. And then the second step was that there would be 5 spirit names of people that you would have to discover. And then you have to contact those spirits in order to open this lock, which was the lock on the door. My room was not word 3, that's just the photo of the lock. So it was a 5-digit combination lock. You had to get it set to the right word. And one thing I liked about this lock was that if you get 4 out of the 5, then you can certainly brute force the last one. Right? So that gives people a little bit of slack. They didn't have to find all 5 spirit names to get this lock. So one of the first sort of technical challenges in this room was I wanted to have the same feature for the box with locks on it. In other words, they're going to find 5 keys, but I thought, well, what if they can't find one? Right? That's really going to be difficult and frustrating. So here's your first challenge for today. Right? So I had 5 padlocks and 5 keys. It's all nicely color-coded with the 5 senses. And what I wanted to do was design a box where I could put 5 locks on it. And if the group got 4 of the 5 keys, they could open the box. But less than 4, it stayed locked. Yeah.
Were they told that, or like
No,
did they just
I
have
didn't
to
tell
figure
them
it like
that. They had
really
to-
frustrated, like we can't find this key?
Yeah, I mean, one of the hints I sometimes gave groups was you only need 4 of the keys to open the box, and they'd be like, "Oh, he's right." So, since this had nothing to do, at least for me, I didn't do any electronics for this. I'm not even going to tell you how I designed it, because it's kind of fun to think about. And if you want, you can ask me at the end, or you can go check my blog posting on this. It's something fun to think about. How do you do this? This was one of the more fun mathematical aspects of this for me. All right, so there's a challenge you can think about. I'm going to give you a few things to do in case I get bored. So there were 5 keys, 1 for each sense. In fact, I wanted to say a little bit about a couple of them, just to get you warmed up. For example, the touch key, so there was a cooler in the room with a bunch of soda in it. And you were supposed to taste the sodas, sort that out, that would open a combination lock, and that would give you the taste key. In fact, the taste key, I put it in a little chocolate lollipop that had the lollipop to get the key out. But also in that cooler was a bunch of ice, and one of the cubes of ice had another key frozen in. You had to notice that one of the ice cubes had a key, and then the good groups, the ones I rooted for, would actually squeeze the key squeeze the ice until it melted, or put it in their mouth, and the lame groups would stomp on it. But either way, they had to touch it. So those were a couple of puzzles I didn't bring because, I don't know, they don't make sense in this context. But the one I want to talk about, because this is an electricity group, is this site key puzzle. So I'm going to give you this. And here you go. You can have one. And there you go. Feel free to think about this while you're not interested in what I'm saying. So there were two aspects to this, and they both were sitting on a table together. There's this thing which I just gave you, which I had bigger, and this object, which I will pass around. You can take a look at it, fiddle with it. So this puzzle involved this grid of colorful letters and this flashlight with knobs on it. I'll see the flashlight with knobs on it. I'm going to talk about a little bit about what this is. All right. So that's a flashlight. So with that flashlight, you shine it on something where I've written in invisible ink, and the invisible ink will show up. So I had a few innocuous-looking signs in the room, things like "Call the math department office if you need technical assistance," stuff like that. But if you shine the shine the blacklight flashlight on it, it would tell you where the key was hidden for this particular puzzle. This key was rolled up in a whiteboard screen like this, and then the whiteboard screen was tucked away above the whiteboard in such a way that most people don't still in my department have any clue that there's actually a whiteboard or a projection screen there. So I think only one of my 36 groups actually searched the room thoroughly, found the whiteboard, pulled it down without solving this. So it was a good hiding spot. It had a nice little, they mostly turned off the lights when they were playing with the black lights. So they'd be chasing this around, and then they'd pull it down in the dark. The key would fall out. So it was pretty cool. So you've seen the flashlight. You have the clue. You're welcome to try and solve this now or when I'm done. See if you get the flashlight to come on, which is puzzle.
Oh gosh, it's in my hand.
Responsibility now.
Oh goodness.
So it's kind of hard to see these pictures, huh? Well, that's all right. We'll take that apart in a minute. Well, maybe not in a minute, but we'll open it up so you can see the guts. So this is actually electricity, right? This is the one thing I did that used some electronics. So first thing I did was to take that yellow plastic flashlight and take it apart, and this chrome cowling that you can see in there, that came with it. And then I took a separate UV flashlight, little pen light, took the operative light bulb part off of it, and super glued it inside of the cowling there. And I had to drill a couple little holes to run the wires through because I had to actually solder wires onto the thing. This is hacked up, but and then to make the knobs, right? That's just a series of these guys. So here's a knob. I brought a knob. You can pass the knob around if you want. So I have 6 of those knobs. And here's a picture of me wiring them up. They're on cardboard just to hold it in place. So I've got a wire that comes in, and each one of those knobs has 6 positions on it. So each knob has a wire coming in on one spot on the positive terminal, and a wire going out on one of the knob settings. And they're wired in series. So as long as you get all 6 of those knobs set right, the flashlight will come on. And if any one of them is wrong, then it'll break this series of wires and your flashlight doesn't work, which is where it's at right now. You can push the button on top, try and make it come on, doesn't come on.
Nope, I'm going to though.
All right, so that was sticking the thing in the cowling was not so bad. Wiring the wires is a little bit of soldering. Probably the hardest part, well, okay, I guess this is next. Color printer, you're wondering what you use color printers for, you print out flashlight dial gauges with them. Tape, drill holes in the thing. And then I got to get the knobs in there. And that was by far the hardest part. I don't know if you guys know how to mount that kind of knob. Does anybody know? So it's got a little peg that sticks up on it. You see there's a little peg right on the side here. And this peg, here's a little peg.
Oh, okay.
Little peg right there.
Okay.
That peg, I think, is to keep the knob from spinning around. But I'm not sure how you're supposed to mount that inside the flashlight. Hello.
Hello.
Welcome to Dorkbot. I'm Brian. I'm talking about the crypto flashlight. I'll get you caught up. Since you've just increased our audience by, I'm not going to say what percent, but it's too large. I'll spend a moment and get you caught up. I ran a puzzle room last fall, and I'm talking about one of the puzzles, which is to get this this flashlight working. Here, why don't you pass it back to them? Take a quick look at it.
Don't be so
Yeah, so that knob has a little post on it, which is supposed to keep it from spinning. And in the end, what I had to do was, starting from the back, put them in there, and then I'd stick my soldering iron in there and heat up that knob enough, that little metal post enough that it sank into the plastic. So that was a project, right? Getting those guys in and sturdy. But they're pretty solid.
That's a nice hack.
Yeah, you know how you're supposed to do it?
I think most, like in commercial applications, you've got a pre-milled part that just
They just fit on.
fits into, but
Yeah, well.
yeah.
So yeah, I had
This
to
is not
sit
a
there.
first
I had to sit there with the soldering iron until they got hot and they melted in.
It was
Tighten them up like all the way so they were like bending.
nice improvisational engineering.
Yeah, nice. Anyway, I knew I had to make it sturdy because I was going to have a whole bunch of people trying to get it to work. One group actually opened it up and solved it by looking at the wiring inside. And then I taped it. Now it's taped closed to say, really don't open it. Really don't. We'll open it up today, but don't open it yet because, yeah, it doesn't open really anymore. The wires have to connect from the flashlight front to the battery pack. So you have to kind of carefully do it. So that's the building of the crypto flashlight. That's sort of puzzle one I wanted to talk about. I thought, since this is stuff with electronics, I put up a spec sheet here. That's the spec sheet for the knob inside. And here's what it costs. So that's a $50 flashlight you're holding in your hand. When all's told, and most of it in the rotary switches.
How much were the batteries? Did you have to?
Oh, I didn't add that. There's two double A batteries. No, 3 AAA batteries.
So it's closer to like $60 almost, probably.
For 3 AAA batteries?
Well,
They usually return batteries or?
No, they're regular old batteries.
55.
I didn't want them dying on me because it's really hard to change because I have to. Yeah, it's hard to change. They're pretty secure. So okay, so that's the crypto flashlight. Again, go ahead and try and figure out how to use this. Turn that on. Almost got it. All right, so that's sort of part one that I wanted to talk about. Here, I'll just, for the slow Joes in the back row. First part of this puzzle was to find 5 keys that would open the box. So your challenge is to design a box where you can put 5 locks on it, and if you only have 4 of the keys, you can still get the box open. All 5 keys, you can get it open. 4 keys, you can still get it open. 3 keys, not enough. That's your design challenge. All right. So when you unlock this box, the 5 key box, groups would pull out this, which, if there were enough college girls in the group, would usually mean screaming. So it's a Ouija board, or Ouija, depending on what part of the country you're from.
I think that's a point worth elucidating.
What?
The pronunciation, I don't know.
Yeah.
You correctly pointed out I think the accurate pronunciation, which I'd never heard.
I don't know. Do people say Ouija or Ouija?
Ouija, you did that.
See, St. Louis is
We do
Ouija.
like Ouija around here.
Yeah. Where I come from, that's what's wrong with you guys?
It doesn't start with a W.
I'm from California. So anyway, they get this Ouija board out. In fact, I have a photocopied one, which I'll say a little bit about why. And they get this object here. So what I wanted to do, and this was on that very first night, part of the original inspiration for this was.
Woohoo!
Got the light on.
Good job.
All right, try to send it all back to white, pass it around, pass it on to somebody else. No, send it back to white.
Get it, get it.
Set the knob back to white.
Oh,
I can't see what you did.
Oh, okay. Yeah.
Yeah.
Yeah, it's kind of hard because once you solve, like you'll solve one and then you'll kind of forget, like, did I get that? You know, and then you have to go back and check the knobs and make sure, like, okay, I got that, I got that.
All right, you got it.
Yeah.
Cool. Did you read anything with it? Did you see anything to read with it?
Oh, you're supposed to shine it? Of course not. No. I just wanted to show you guys.
Okay, so the idea was that they would solve these other puzzles that were more word-based puzzles to come up with names of spirits, and then they were supposed to take the Ouija board, slide this around on it, to spell the names of the spirits, and the spirits would speak to them from a hidden speaker. So that I thought I could make that work when I started. So that was sort of the big design challenge number 2 for this was, how do you make a Ouija board that players can actually use to contact spirits? So that's, I'm going to say a little bit about that. Yeah, so the spirits, when they contact them, they speak out of a not particularly well hidden speaker in the ceiling, and tell them one of the letters on the lock on the door. So they had to get. Some groups got out with just 3 spirits. They were able to guess the lock combination. You probably needed 4 before you could reinforce it, and if you got all 5, then you got a little special bonus. Yeah. Let's see if my mouse is working. Oh, yes, it is. So that's just a wireless mouse. Optical wireless mouse in there. And so when you drag it around on the board, the computer can detect it. And it's pretty good for distance. The room I was in was much smaller than this one. So I had the Ouija board in the center, very close to the computer, unless they decided to go off to one of the corner tables for some reason, which one group did. It worked pretty well. As far as connecting with the computer. All right, so this is the technical part. So here's the equipment I had for this. I bought a Ouija board to make it look authentically corny. I'm kind of embarrassed that I own a Ouija board now, but I do. This is an old wireless mouse. I probably should have bought a new one because they're much smaller these days. But this is one I had around and wasn't using. And I severed the top off of it to make it a little lower profile. So it doesn't have buttons anymore. Then I needed to make it look like the Ouija board planchette, is what it's called. So I wanted some nice looking wood, and I had a cigar box. I don't smoke, but I had some cigar boxes from previous projects. So this is old cigar box wood, and I thought I'd show you what was left of the cigar box when I was done with it. But it looks nice. It's nicely finished, and you can even see on the back. So, and then this is my old MacBook. This is what I ran the room on. Not my #1 computer anymore. All right. So how does this work? Right, when you, I got to tell you a little bit about mouse movement. When you move the mouse, as you slide it around, you can see it moves quite a bit. There's the mouse pointer. And as you track from one letter to another, the computer is going to get a lot of mouse movements. And what I wanted to do was somehow be able to tell what letters they had slid to with this pointer thing. Another thing I was worried about was, would they do it like this? Would they do it like this? Would they put them through the hole? Would they point at them? So I wanted to have something that was robust to various craziness that they could do. But so the first problem is you want to track the motion of this thing. And if they make a full slide from, say, N to E, that's going to come as a bunch of tiny little increments from the mouse. So the first step in this process was to take those tiny little increments. Here's the tiny little increments. So that might be a slide from N to E. And what I would do is, as long as the mouse was still moving, and I had like a half millisecond, it had to stop before I considered it stopped. I would check it and see where it moved to, and I just add those up to make one vector. Right? So they had to pause at each letter, but groups were pretty good about that. I gave them explicit instructions in the box, to stop each letter. Some groups thought they actually had to chant the letters. They spelled them because they thought I was listening. But I think if I'd done that, I would have been in trouble because not every group did. And I couldn't count on them to say the letters out loud. I didn't also want to have to pay that much attention. Okay, so step one, add up a bunch of vectors to get a mouse motion vector. Right? So this mouse does a sequence of motions. And I want to detect what those are. Now I'm going to get really a little more technical. So let's say they've done a slide from there to there, there to there, there to there. I don't actually know where on the board this thing is happening. I just know the motions. So I have these mouse motions, which I'm using a little math. Get a little math in. So this would be like the first mouse motion, second mouse motion, third mouse motion. It's just going to have a stream of those coming through the program. And I convert them into distances and angles. So this sequence of moves is now a move that is some distance, followed by another move of some distance, and in between, wow, this is too tall for me. In between this move and that move, there's an angle. So if you remember your math, you can compute that very easily, that angle with dot products. So in fact, you actually naturally get the cosine of the angle. That's fun. So I took this sequence of moves, turned it into distance and cosine of angle sequence. All right. This is the slide where you get to think about your alphabet puzzle into it, but I thought I'd at least give the full-on technical details about this one. So before this show started, I sat down and spelled all the spirits that I wanted to spell. And I recorded the sequence of distance and angles that I got. So that's each one of the spirits has a sequence of distance and angles, one less than the number of letters, because that's how many motions spell it. Then I took my incoming sequence of distance and angles and just compared it with all my sequences. So I take the difference in distances at each step, right? Difference in angles, or cosines of angles at each step. And then the natural thing to do is to square them all and add them up. So this is least squares fit. I'm doing a least squares fit of distance and angles to my pre-recorded motions. I actually didn't think this would work really very well when I started. Thought I'd have to do all sorts of artificial intelligence matching and tweaking, and it worked. So it's nice when the first thing you try works and you don't have to do the complicated stuff you were thinking of. So I have these two numbers, one which is how close was the sequence of distances, one which is how close was the sequence of angles. I want to combine them to get some kind of measure. They're on totally different scales. This number's in the thousands. This number is somewhere around like 1, somewhere in the 0 to 3 range. So you take logs of both of them. That puts them both on equivalent scales. add them up, and then I put a little fudge factor so I could weigh the angles more or less. In the end, I had to make the angles work a little more. It worked, but I had one tweak that I could do. So you do this, and if this number is small, it means your distances match pretty well. If this number is small, it means your angles match pretty well. So if this number is small, it means you match that spirit pretty well. And so for each spirit, I just went through and had some threshold, and if it got below that threshold, the spirit was expelled. And there were a few false positives, but for the most part, this worked pretty well. That was the technical mathy slide. Anybody have technical mathy questions they want to ask? All right. So I'm going to do a little demo. This is the data you need for one spirit. So my smell spirit was Chanel, Coco Chanel. The puzzle for that was I had 12 little transparent cards, and each one had a scratch and sniff sticker on it. And if you smelled the stickers, you could find that they actually matched in pairs. And there was a little tray with pictures of what the scents were. There was mint and rose and chocolate. And so if you smelled them and you put them in the right slots in the tray, the two transparent cards would fit together and make a letter. And then that spelled Chanel. It's a very hard puzzle, maybe the hardest puzzle in the room. Turns out people smell terrible, right? Yeah, people are not good at smelling. So it's very hard to solve this one.
I think sometimes we can just be like amazed, like if you smell something and you don't know what you're, it's not labeled.
Yeah, exactly. Right. And if you do like scratch and sniff books, it'll be like, and now little bunny smells pickles, right? And there'll be like pickles all over the page, and the sticker's got a pickle on it, and you smell it, and like, wow, that smells like pickles. But if you take that sticker and it doesn't say pickles, and it's not green, and it's just a, and my stickers were all orange.
Yeah, that's kind of great.
It's pretty hard. Oh, what'd you find?
It's making noise for the last 20 minutes.
Hey, look at that. You were sitting in the right spot to find that. You just solved you would have found the sound key if you were in my room. So, I don't know if you heard, you heard the little girl over there.
I swear, I was like.
That was a kid's toy or something.
Yeah.
This freaked people out to no end in the room. I hid this really well in the underside of a chair, not even better than that. And of course they're in the room. They're in the room. They're talking. They're working on one of the puzzles. They had to listen to a CD, so there's music playing. And this is a recording of my daughter saying various attention-grabbing things. It starts off with 10 minutes of silence, and then every few minutes she says something. It gets more and more frequent, louder and louder, until it's almost impossible to keep going. So many groups would argue and yell at this thing, which was hidden. Saying stuff like that. Yeah. Anyway, when they found it, it had a key in the back and bring the key. So there's no box. So I think I'm going to turn her off. This does have a passcode on it. Listening to the CD was how they got the passcode to unlock this. And then there's one more puzzle on here, which I'll play for you. So there you go. You know what that is?
Morse code?
Morse code. And I don't know if you can see on the
That little cheat sheet thing?
I don't know if you can see on the screen, but the album art for that puzzle is no. I'm gonna hold it up. Yeah, the album art is this little Morse code. Oh, I can't make it happen. Well, anyway, there's a little cheat sheet Morse code. Turns out it's also very hard to learn Morse code on the fly. Puzzle around. So that was That Morse code spelled Mozart. He's the sound spirit. So, thought I'd bring that. My daughter was described as creepy, probably more than half the time. Okay, so if they solved, say, the smell puzzle and got Chanel, or the sound puzzle and got Mozart, then they would spell it on this Ouija board. For each one of these characters, I had to do the spelling myself, and then I would get a sequence of numbers like this. You can see the distances are in the thousands, and the angle numbers are pretty small. Take a look at the Ouija board, the way it's laid out. For example, Chanel, you go C over to H, and almost directly back to A. And so the angle you're making when you do that, this vector is pointing almost directly to the right, this vector almost directly to the left. The angle between them is then almost 180, so its cosine is pretty close to -1. So just sort of interpret this. Now the cool thing about that is that if you decide to hold the thing like this and move it around, right, you're making the same angles, right? Same distances, same angles. If you hold it upside down, same distance, same angles. If you use the point, you use the hole, you still have to make the same distance and angle motion. This may be another good time to explain why I have a photocopy Ouija board instead of the original one that I paid $20 for. I did all my testing on photocopies because I didn't want to mess it up. And then when I bring out the original Ouija board, everything stopped working. Couldn't figure out why. It took me quite a while to realize it's too shiny. And it wouldn't track on it. So then I had to provide them with this kind of credit thing. That was a little easy. I think a modern optical mouse could have done better. All right, so let's demo this thing. It's fun. You guys can come up and spell it if you'd like. All right, so I had to write this Python application to manage the room. Ostensibly, it was just doing a countdown timer, and that's what I told people. So this would, I'd go full screen with it. Go full screen, see what it looks like when you're in the room, except now we're in like the huge countdown. Yeah. That's very threatening, right? All right, then I'm going to come out of full screen. Oh, please work. So all I saw was this full screen thing, but behind the scenes it was running the recognizer. So you guys are welcome to come up here and try spelling something on the Ouija board. Somebody brave who feels like they're in touch with spirits today. I've told you 2 of the spirits so far. You could try contact Chanel if you'd like, or Mozart is the other one we've met.
Hello, this is Coco, of course. It is so wonderful of you to call on me. Do you know my perfume? The number 5. Alas, your silly log has only a number 1 in it. I suppose it had to be 1.
All right. So I went around and hit up all my friends for voice acting. I made a bunch of voice recordings. Chanel, I thought, did a really excellent job. So you can see a little bit of debugging output as this is running.